All right, so for number five here, there will be one question just like this on the quiz tomorrow. So yesterday we did a couple of questions about the cube root. So the thing is, we want to have scenarios such that the cube root and the cube could be canceled out, right? So if the exponent it's a number divisible by the index, in this case 3, that would be lovely. So you gotta be very sensitive. So I mean, y to the 12th power, that would be a very lovely thing to have. But then the other two are not so pleasant, like the 16 and the x to the 8th power. So what does it mean? Well, we can at least do this because we don't have to jam everything together. You can do this separately. Okay. Now, by the way, let me just go ahead and give you a little brief introduction of all these radical stuff. So what I want to say is this. What I'm showing you is a thought process that as a beginner, you probably want to learn how to see things like this. But later on, okay, as you do more of this process, this would actually be just a part of your mental process. You would not need to write them out, but for the moment, this would be, I would write this down and I would make it very explicit so that you would not be lost, okay? So now, so cube root of y to the 12th power, it's very easy, like for this one. What does that become? Cube root of y to the 12th power. Okay, so yesterday I went over 2 ways to do it. One way to do it is that you can look at it this way. Why would you want to look at it this way? Because the cube and the cube root, the inverses, and they're going to cancel each other out. Okay, so what's left? Y to the 4th power. Okay, so that's how you look at y to the 12th power, a different way, and then you can simplify it easily. The other way to handle this is that you can always divide the exponents by the index. Okay, you can divide the exponents by the index. So 12 divided by 3 is 4. So that's how you get y to the 4th power. Okay, but you should have both ways in your pocket so that you know how to see things properly. So that's just y to the 4th. Okay, but now what about cube root of 16 and cube root of x to the 8th power? How do you handle those two? Well, 16 is not a perfect cube. But what is a perfect cube? 8. Okay, that's related to here. So what you can do is to break down a 16 into 8 and 2. Okay. All right. And then you can look at the x to the 8th power. Well, 8 is not a multiple of 3. But you know what is? 6 is. So that means you can change the way you look at x to the 8th so that you have x to the 6th power and x squared. So therefore, you can look at, now I'm going to do it really slowly so that you can see what's happening. But this step could be skipped if you are understanding what's happening. Okay, so cube root of 8 is 2. Now you would just leave cube root of 2 because you cannot do anything about it. Cube root of x to the 6th power, x squared. cube root of x squared. Can't do anything about it. And then y to the fourth power. So you group all the ones outside the roots together. So you have 2x squared, y to the fourth. And then you have cube root of 2x squared. Okay. So it's a bit of work. Okay. So that's how you simplify things out. All right, so now this is how I would break it down one by one. Now, I'm going to explain to you alternatively, and some of you might enjoy the other way better. Okay, so but for now, I want to make sure that I show you the actual step-by-step process. How do you analyze this? How do you know how to simplify it? Okay. If you're okay with this, let me go ahead and let me just delete it for now. Okay. So some people might choose to do this. Now, if you are a person who believes that you are pretty smart and you can handle some work mentally, so this might interest you more. So there are three things basically that that is our interest at the moment as we try to simplify this. So what we think about is, all right, is there any cubic things that we can simplify? So I'm going to write down the cube root right here. So I'm going to analyze one at a time, these items one at a time. So 16, like earlier we said 16 is 8 times 2, right? So that means that 8 could be cube rooted to become 2. What's left inside the cube root? 2. X to the 8th power. What could be cube rooted? The x to the 6th power could be cube rooted to become x squared. What's left underneath the cube root? X squared. What about y to the 12th power? Well, the whole thing could be cube rooted to become y to the 4th power. Done. Okay. Now, this, with more practice, would be something that you want to do down the road because it's more efficient. And by the way, please do yourself a favor that when you write exponents or the index of the root, make sure that you write them as a superscript, meaning that when you write your regular numbers, write it bigger. And then when you write the index or the exponent, write it relatively smaller. Because if you write them about the same size, the only person you're confusing the most is yourself. Okay, you don't want to mislead yourself and then you do the wrong thing at the end. Okay. Yes. Very good question. Would you need to consider the absolute value or the even odd thing here? You would not need to, because the absolute value is when you have to account for the possibility of it being negative, right? And we don't know. So that's why we say even odd. Even index, even exponent, and odd power at the end. And right off the bat, this is not even. So that's why with odd root, okay, if it's a cube root or later on maybe the 5th root, you don't have to worry about absolute value symbol at all. Okay. Okay. All right.